Hi, my name is Phi Nguyen and the student ID is 10148823. This is a video to demonstrate my assignment 2. So first of all, to start with, we gotta find the path of iris CSV file and save it in a variable called file name. After that, we're gonna read the content of the file and save it in a variable name is iris. So the next steps is to show the first 5 rows of the data frame. Okay, so you see the last column contains the string. So we want to convert these strings to integers and we can work with them easily in our neural network model. So setosa equals to 0, verse color to 1, and verse Shanika to 2. The next step is to convert the last column strings to integers. So iris species equals to iris species.map, and we map them to 0, 1, and 2. And now we check the first 5 elements with iris dataset once again, and using the dot head, you can see they're all 0, and select the first 4 columns of data frame as the data and call the data X. Select the last column as the label and call it Y, and now is the time to split data X and the label Y into training and testing segments. Call them parse X train, X test, Y train, and Y test. Split the data and label to training and testing segments. So Y the size of test data is 20% and use random state equals 1, 2, 3 to make all the answers similar to in the whole class. So the next step we're going to do is check the first 5 row of X train, X test, Y train, and Y test. So this is the result. Okay. The next step is to check the length of X train and X test. If the numbers are 1, 20, and 30, it is good to go. The next one is to convert Y train, Y test from categorical to 1 hot encoded values and call them 1 hot tray labels and 1 hot test labels respectively. The very next step is to find a sequential model that contains 3 dense layers. In the first and second layers, use 100 hidden units, neurons, and a ReLU activation function. For the last layer, we need to use 3 as the number of outputs, and the reasons why we have 3 classes: Setosa is 0, Versicolor 1, Virginica 2. Also, please pick an appropriate loss function for the last layer. Now, compile model using ORM's prop optimizer, an appropriate loss function, and accuracy for your metrics. The next step is to train the model using epoch equals to 20 and batch is 10. Step number 8 is calculate the result, evaluating X test and 1 hot test label, and report on the accuracy of your model. And now we repeat all we have done in 6A with the following parameters. Next step is use the same settings for 6B, compile using the same optimizer loss function and output the accuracy. And we're gonna fit our model using epoch equals to 4, batch equals to 10, and to calculate the result, evaluating X test and 1 hot test label, and report on the accuracy of the model. I'm gonna go ahead and answer question 10. So the first question is how the number of layers or hidden units impacts accuracy. So in my opinion, more layers and more units equals to the model can learn more complex patterns. Model 1, 100 units, 20 epoch, can have it gets higher accuracy than Model 2, 10 units, and 4 epoch. For too many layers and or units on a small dataset like iris, only 150 samples can lead to overfitting. The model memorizes the training data instead of learning general patterns. So question number 2 is, do we always suffer from overfitting? The answer is no. Overfitting is more likely when the model is too large for the dataset. You train for too many approach. The dataset is too small. So a simple model with a few units, like Model 2 with 10 units, is less likely to overfit, but might underfit instead, not learning enough. So how can we defect overfitting? The solution is to have the training accuracy keeps going up, but test accuracy stays the same drops. That another solution is big gap between training accuracy and test accuracy equals to overfitting. You can track this by using validation data or model.fit function and comparing training versus the validation loss accuracy. So how can we reduce overfitting? Use fewer layers or fewer hidden units, simple layers, and use fewer epoch, early stopping, add dropout layers, randomly turns off neurons during training, add more training data, use regularization L1 or L2. So move on to 10B experiments. Question number 1, optimizer. So we use Adam instead of RMS prop. Adam adapts learning rate per parameter, often converges faster. May get slightly different accuracy, both are good for this task. So number of layers, added a third hidden layer. So more layers equals to more capacity to learn complex features. For Iris, a simple data set, an extra layer probably doesn't help much, could hurt with only 4 push. 3 hidden units, 50 instead of 10. More neurons means more learning capacity, accuracy likely improves since 10 units might be too few to capture patterns well. In push, 15 instead of 4, more training passes over data, more time to learn, accuracy should go up significantly. For a push is very little, but too many push risk overfitting. Batch size, 5 instead of 10. Smaller batches, more way of days per push can converge faster, but noisier gradients, less stable training on a small dataset. The difference is minor. And that's pretty it for my video, and thank you so much for listening.